to the cloud so that people who are not attending live uh, can watch this. Okay, so then just let's give people a minute to join. Okay, so I'm of the understanding that Professor Mera is here. Would you like to introduce yourself and kickstart the class, which is my final class, in anticipation of you taking over for next week? Would you like to do that, Professor
Yes,
Mera?
yes, thank you. Hello, everyone. My name is Mehran Tirandozian, and I'm excited to be your professor for the rest of the semester. I'm looking forward to getting to know each of you and guiding you through the course materials. I understand this may be a transition period for you, so please don't hesitate to reach out if you have any questions. I will be uploading the course material by the next week. Thank you, Professor Sajjad, and hope you have a wonderful vacation.
Thank you. Does anybody have any questions for the professor? As I've previously stated, this is my last class with you. So from week 8 onwards, Professor Mera will be taking over. So do you have any questions for Professor Mera while we are both present? Professor Mera, do you see the question from Teresa?
Yes,
Okay. So the question is, will there be Zoom meetings?
yeah, we will have.
Okay, you'll have Zoom meetings.
Yeah,
Uh, Professor Mera, just before while we have you here, I just wanted to point out, so we will finish assignment 3 this week, and then they
okay.
will have test 2, which I don't recommend that you have in week 8. I would recommend you push it back. Um,
Yeah, yeah,
so, but test 2 and 3 and assignments 4 and 5 will remain.
yeah.
Uh,
Okay.
okay, and are you able to let them know where you will post the links for the Zoom meetings in the same place I posted them, or?
Yeah, the same place. It's same place, Professor.
Okay, okay. All right. Well, what I was doing is that the recording them because this is an asynchronous class, so I'll leave that up to you. But does anybody have any more questions? Paloma, Josh,
I
Matt,
want to know if the meetings will be at the same time or a different date, different time.
I will let you know next week. Hopefully, it will be the same time as the Professor Sajjad.
All right, perfect. Thank you.
it looks like nobody else has any questions. Abdul, Tammy, Chai. Okay. Here's a question from Elizabeth. Will their Zoom meetings still be recorded?
Yes,
Okay, great. And I'm assuming you'll post the recording afterwards. Hopefully that answered your question, Elizabeth. Okay, Professor Mera, if you want to head off, thank you for
yeah.
stopping by.
Thank you very much.
Take care.
You too. Bye bye.
Okay, so that ends that. We will be having our last class today, and we'll we'll try to work through some of the assignment as well, so that you can have a good start. Okay. And worst case scenario, I'll give you guys hints on how to perform or how to calculate the answer for assignment number 3, not 2, 3. So before we start, any questions for me? So I guess none. So what we'd like to work on now are moments, and we'll talk a little bit about couples and Varignon's theorem, and we'll work on some practice problems. So basically, the Varignon's theorem states that the moment of a force about a point is the algebraic sum of the moments of the components of the force with respect to the same point. So what does that mean? That instead of calculating, because it's complicated. Like if you look at this F, it can be a little bit challenging to determine what this perpendicular distance is. So let's go back to a very important point that we've been talking about in the last part of our lectures before we took a break for the test. Remember, if you're looking at a point A as the axis of rotation, and you've got a force whose line of action is this, in order to determine the moment around A, you need the perpendicular distance. But that can get very, very complicated. So in this case, it might not be complicated, right? So let's say this is a structure or a door, and it's still against A, but the force is actually acting in this direction. So Ragnall's theorem, what does it say? That you can split this up into its components. So Fy and Fx. And then you can calculate the moment around this. Why? Because this might be a lot simpler. The perpendicular distance might be a lot easier to calculate as opposed to, in this case, where the perpendicular distance is actually this much, but it might be a little bit hard to calculate. So that's what's going on here. That's what we're trying to achieve. We can now use Ragnall's theorem to calculate the sum of the moments around an axis by using the components of the force. So in this case, if you've got F and you're trying to calculate the moment, the moment of the force F around A, you can split it up into its Fy component and Fx component. Because hopefully the perpendicular distance for this would be easier to calculate. And then all you do is you then add the moment of the force because of the y component to the moment of the force because of the x component. And that will give you your moment, the sum of the moments. And just remember, Fx, the moment is going to be in a counterclockwise direction. Whereas the moment of the force Fy is going to be in a clockwise direction. Always remember, clockwise direction moment is negative. Counterclockwise or anti-clockwise, the moment would be positive. That's basically what these notes are signifying here, that you can now compute the sum of the moments using the components. So let's try to work on a scenario. So we've got a wind of 2,000 pounds at an angle of, and I'll give you the angle, from the horizontal. It's applied at a joint A on a roof truss. Determine the moment of the force F about the supports at B and C and the crown at D. So we're going to use the principles of the moments to calculate all that. So the first thing I want to point out here is that we've got the force is 2,000 pounds. It's at an angle of 50 degrees. So the first thing you want to do is break it down into its x and y components. How are you going to do that? You are going to simply use the angle 50 degrees and use SOHCAHTOA. So now that you have Fy, which is 1,532 pounds, the force is 1,532 pounds, and you have Fx, 1,286 pounds, you can now use this information to calculate the moment around the different points. So let's start off with calculating the moment around B. So if you guys could open this up on your computer, because I can't, I would rather have the focus of the camera on this board or on my desk. To approach this. So let's take a look at B. Let's try to calculate the moment of the force around B. So if you look at the figure, moment around B is going to be equal to, so Fy, and if you look at the distance, you can see in the figure that its perpendicular distance to B from the line of action of the force is 10 feet. Multiplied by 10. The next question is this clockwise or counterclockwise? It looks clockwise to me, so I'm going to put a minus here. Now let's take a look at Fx. It also looks clockwise, so I'm going to say minus Fx, and the perpendicular distance is 5. Now plugging the numbers in, minus 1532 times 10 minus 1286 times 5. Let's go ahead and run those numbers. So that should be minus 15,320 Okay, I've done something here. 1286 times 5 is equals to 6430. So what is my total? So it should be 21,750 pound-feet. Let's go back to so does this make sense? Right, Fy, that's already done. So when you take a look at the solution, so yes, minus 1286 times 5, minus 1532 times 10. So yeah, there you go. We got the right answer. So what I'd like you guys to do is to get the moment of Fy and Fx, the sum of the moments, are on D. So I'll give you guys a few minutes to try to do that. Okay, so for MD, I can see that my line of action, Fy, is 10 feet from it, and it is counterclockwise, so I'll leave that as positive. And Fx, which is also counterclockwise, so I'll leave that as positive. Fx times 5. So what does that give us? 1532 times 10 plus 1286 times 5. Answer is 15320. Again, 21750 pound feet, but this time it should be positive. So let's now focus on the slides and see how they've handled it. So MD, 5, fx times 5 plus fy times 10, and 1286 times 5 plus 1532 times 10. So, yep, they've got the same answer, pound feet. And MB can also be found that way. Any questions about this?
I'm a little confused about why D was 5 feet instead of 10.
Here, so let's take a look at. Are you referring to MD when I was calculating MD or
Yes.
MD? Okay, so MD. So we multiplied fx by 5 feet. If you extend the line of action of force of fx all the way across, what is the perpendicular distance between that line and D? Is it going to be 10 feet or
10.
5 feet? Why would it be 10 feet? The line of action of force passes through here. What is the distance between the line of
Oh,
action?
okay. I see. I see.
Yeah. So just
Okay.
extend this and then look for the perpendicular distance.
Okay, I understand now. Thank you.
And that's going to be the main challenge, trying to figure out those distances. If you can figure that out and you can remember clockwise and counterclockwise, you're going to do quite well with this part of the course, moments of forces. If you don't, that's where the errors set in. So the next example. Oh, well, not example, just a brief discussion on a couple. It's basically an arrangement of forces that creates a rotational effect, and it's a series of parallel forces. And so that's another type of problem that we're going to be solving, where we've got forces that create rotation of a structure or a plank. Okay, but the principles are the same for the calculations. Oops. I don't know what's going on with my. But this is the first example. So in order to solve this, right now what I'm going to suggest is that you just work on determining the rotational force, the sum of the rotation around A and B. So let's go ahead and try this. So what I'm going to do is I'm going to solve the sum of the moments around A. That's the first thing I'm going to do. But just remember, you've got the plank-like structure. You've got A, and then you've got B. And you've got 5,000 pounds or 5 kips here, 14,000 pounds or 14 kips here, and 6,000 pounds or 6 kips here. So open up, so make sure you open up your figure so that you know what you're looking at. So let's draw this with a different color. This entire length is 20 feet. Very important. Next, what I'm going to draw is this distance here is given as 3 feet. This distance from 5 kips to 14 kips is given as 7 feet. This distance is given as 6 feet, and this distance is given as 4 feet. So for the moment around A, let's calculate the moment around A. So MA, so the sum of the moment is going to be what? 5 kips times, what is the perpendicular distance? It's from here to here. The line of action of the force, 3 feet. So that's number one. Is it counterclockwise or clockwise? It's clockwise, so it's going to be negative. Remember, if you were to push something around A in this direction, it's clockwise. So they're all going to be clockwise. So it's going to be 14 times 7 plus 3 is 10. 6 times 6, what is this, 10? So that will be minus 6 times 16. So that'll be minus 15, minus 140, minus, what is that? 6 times 16, 96. What is the sum? 140 plus 15 is equal to minus 251 kips feet, pounds, 1,000 pounds feet. Remember, what does kips mean? It's 1,000 pounds. That's what that means. So what I'd like you to do now is calculate MB. Got all the forces given. You've got all the distances. Now you're going to be calculating MB, and it's going to be counterclockwise, so that'll all be positive. So I'll give you guys a few minutes to try to calculate that. Okay. So Josh, I'd recommend that you uh, pin me, otherwise it gets hard to see. And you should have this open on your computer, the actual problem from the slides. Otherwise, you're going to struggle to follow. Okay, let's take a look at MB. MB, so for MB, the sum of the moments for MB, it's going to be 5 multiplied by, what is that, 7 plus 6 plus 4, 17. And is it going to be positive or negative? It's positive. Same for 14. 14 plus, sorry, not plus, times, 14 times 6 plus 4, 10 plus 6 times 4. They're all going to be positive. 5 times 17, 85 plus 140 plus 24 is equal to 249 kips feet. That would be your answer. Is anybody unclear? Take-
If this is static, wouldn't say for A, wouldn't there be a counter torque on B that would?
Yes, there would. Yep,
Okay.
there would. So what you've just mentioned is exactly correct. In reality, what ends up happening is that there is a reaction, RA, from the Earth, and there's a reaction, RB, from the Earth. And actually, that would be countering the moment. So yes, you are exactly correct. But if you're just calculating the moment, that is what we're getting. And at some stage, yes, you will be getting the reactionary force from the Earth. That's in an upward direction. So if the plank is in a downward direction, it's pushing down on B, the Earth pushes back up. That is correct. Good point. So the next thing that I wanted to bring up, so if you go to problem number 4.16, 4.16, you will see something that's quite important. You will see that you're given a number, 2,000 kips per feet for a structure. But that structure, you're told, is how long is that structure? If it is 16 feet, what is its weight going to be now? If its density is 2 kips per feet and its length is 16 feet, the weight is going to be what? 2 times 16 is equal to 32 kips. But where are we going to show that force? Right in the center. Why? Because it is a equally proportioned. If it is a regular body, like a box or a plank, and if you were to split it down the middle, it would be a exact image of each other, both sides. You can just show the force acting in the center. However, if you have an irregular body like this, and you're showing weight, where will you show the force acting down from? Well, you have to calculate center of mass, center of gravity, and that's what you're going to be doing towards the end of the course, because this is an irregular shaped body. But right now, you don't need to worry about that. That's coming up later on. That is something that you will become familiar with as you come closer to the end of the semester. Okay, so now you've got two structures, basically, sitting on top of each other. I'm going to draw it a little bit different than what the book has it. This says 2 kips per feet. This says 1 kip per feet. This is 16 feet. This is 26 feet. How do I know that? Because this distance is given as 10 feet. So what you're going to do is you're first going to use what we did here, calculate. This is 32 kips. And it's right in the center. So it's 8 feet in each direction. And then what is this? 26. So this is going to be 26 kips. How did I get that? Well, it's 1 kip per foot and there's 26 feet. And it goes right down the center. So this is what you need to focus on. Just figuring out what the total weight is going to be that you're going to show. And where it's going to go down from. So in the top structure, it's going to be going down from the center, and it's going to be 32 kips. Why? It's 2 kips per feet, 16 feet times 2. The bottom one, it's going to be going down from where it's going to be 13 feet. Guess I'll let you guys try to calculate the moment around A and the moment around B, and then I'll see what you guys get. Okay, let me try to solve that for you guys. The way this is now set up, once you've determined based on the density what your two planks are weighing. This is the first plank, second plank. So we know this is 32, and we know this is 26. So at A and B, what are the moments going to be? Well, first you determine the distance. So we know that this is 16 feet, so that means this is 8 feet. So moment around A, because of this, is going to be 32 times 8. Now the question is, though, is it going to be clockwise? Yes, it's clockwise, so negative. And it's 26. Remember, this entire length is 26, so this length to here will be 13 feet. So this is going to be minus 26 times 13. 32 times 8, 256, minus 26 times 13, minus 338. So that's going to be minus 594, and the unit will be Gibbs feet. Did you guys solve this? And if you did, is this what you got? And if not, why not? What is the error? You can do the same for MB. MB, how is it going to be? So it's virtually the same, except here's the thing. This is 8 feet. And this is also 8 feet, right? Or this is also 8 feet. Then what about this? How much is that? Well, this is total is 26. So 26 minus 8 is what? 18. So it's going to be 32 times 18, and it's going to be in a counterclockwise direction, so it'll stay positive at 26 times 13. So you should be able to get 32 times 18 is equal to 576 plus 338. So the answer would be 1152 Gibbs feet.
Sir, I got a different answer. I got 914.
Okay, that might be correct. What do you get? So did you use for 32? Did I use the right number?
Yeah, it was just the last calculation.
So is 26 times 13 is 338. So maybe I made a mistake here. This might be wrong. Let's double check this. I might have added it incorrectly. So 576 plus 338. Yeah, 914. Thank you. I must have fat thumbed it. So the actual answer is 914. Let's try to do one more example before we move on to a break. Take a look at this question here. Here, so how are we going to solve this? Let's take a look. So there's only two of the values are given. $8,000 and $3,500. But then you've got 600 pounds per foot. So let's go ahead and try to solve this. Switch the camera. So we have we've got a plank and we have a weight at this location, 8,000 pounds. And we have another weight at this location, 3,500 pounds. And then we have something in the middle, which is 600 pounds per foot. Do we know what this is? Do we know the width? Yes, we do. It's 12 feet. So 600 times 12 is equal to, let's go ahead and calculate that. 7,200. 7,200. And where are we going to show that? Right in the dead center. Dead center. And that way, we now have all of the weights shown. And we have the distances. So when you look at the distances, you can see this is 3 feet. How much is this? Since it's dead in the center, this will be 12 feet. And this is 2 feet from here. So how much is this distance from A? 22 feet. So using that information, you can calculate the moment around A. If you look at the figure, compare it with the numbers that I have. Make sure that I'm not incorrect. And then calculate moment around A. Let's see if we get the same answer. Okay, let's go ahead and solve this. So MA going to be equal to 8,000 times 3 It's clockwise, so it's going to be negative minus 7,200 times 12 minus 3,500 times 22. So that should be 24,000 minus 200 times 12, 86,400 minus 77,000. So your answer should be, hopefully I get this right, 24,000. 187,400. And what is the unit? Pounds, feet. That is the moment around A. You basically do the same thing to get the moment around B. In that case, what you're doing is it's going to be positive because it's counterclockwise. 8,000 times 21 plus same 7,200 times times 12 plus 3,500 times 2. Whatever the answer is, you should express it in pounds feet. So there you have it. Any questions? I find that this type of exercise, these type of calculations, that the best way to approach them is to just break everything down, try to look at the structure in as simple a manner as possible. Okay, so let's erase this, assuming you guys are understanding this. So when we come back, we'll work on this example here. All right. So see you in a few minutes. Okay, so let's take a look at this scenario here. So this scenario, don't stress out at all. It's actually quite straightforward. 4.19. You're trying to determine the moment around A. Remember, you've got 1, 2, 3, 4. You've got 4 different forces that you're dealing with. And very calmly, just take a look at the line of action of each force, the perpendicular distance to the axis of rotation. And then we'll proceed accordingly. So for the first one, 4 kips around A. So I'm going to calculate it around A. 4 kips. Times 15. And it's clockwise, so it's going to be negative. Then it's 12 kips times 15 plus 15. Look at it closely. That's 30. Minus 5 times 45. Minus 8 times 45. It's 4 times 15, that's minus 60. 12 times 30, minus 360. 5 times 45, minus 180. 8 times 45, 360. So your answer should be minus 960 kips feet. It's for MA. For NB, it's going to be, so these are all counterclockwise, so they'll be plus. So it'll be 4 times 45 plus 12 times 30 plus 5 times 15 plus 8 times 15. Remember, we're looking at B now. It's 180 plus 360 plus 75 plus 120. The answer is plus 75 plus 360 plus 180. 735 feet. Is that clear to you guys? Just to refresh.
Can you check your 8 times 45, I think?
What is 8 times 45?
Or was it 5
Let's just check this.
on MA?
For some reason, I'm having a hard time. Oh, did I miscalculate that?
I think maybe.
I might have. So 8 times 45, should it not be 360?
Maybe it was the
Um,
5.
I think,
Five.
yeah, I think it's the 5.
That was it.
Pardon me?
It was the 5 times 45.
5 times 45. Okay, so what should that be? 5 times 45. Did you get
225.
225? Should be 225, not 180. So your answer, what is your answer?
Negative 1005.
Negative 1005. That is correct. That is incorrect. Negative 1005. Do you guys feel comfortable enough to attempt the assignment questions now? Or should we do one more? Should we do one more? And
Yes,
then
can we do one more?
you want to do one more? Okay.
Yeah.
All right, let's do one more. So do you guys want to do this one? So in this case, it's a little bit different from what we've been doing now. In terms of A, moment around A, it's everything's the same. So what I'm going to recommend that you do in terms of A would be 6 times 2, but it's going to be negative y, it's clockwise. 7 times 6 and 8 times whatever this total is. 6 plus 8, 14. So 14 times 8. For B, it's going to be interesting. It's going to be 8 times 3, and it's going to be clockwise, so that's going to be negative. But it's going to be 7 times 5 and 6 times 9. And this is going to be counterclockwise. So that's going to be the difference. So go ahead and try to complete that. And then I think we should start working on the assignment so that I can give you some time to work on that. And also you can give you some tips so that you can submit it and get the marks by the weekend. Okay, let's go ahead and solve it. Hopefully we'll get the right answer. Okay, so this is, I would do this for MA. So it will be clockwise, so it's going to be negative. 6 times 2 minus 7 times 6 minus 8 times, how much is that? 6 and 14. Correct me if I'm wrong. 14 minus 12. Go ahead and get the calculator. So I think this is 42. 8 times 14, 112. Well, I'm getting 166 pips feet, and it's negative. Hopefully that's what you guys are getting. For B, since it's counterclockwise, so 6 times 9 plus 7 times 5. Now 8 is going to be clockwise, so it's going to be negative. 8 times 3. So 6 times 9, what is that? 54 plus 35 minus 24. 54 plus 35 minus 24. So the answer should be 65 kips feet. Are you guys getting the same answer? Or am I in error somewhere?
Yeah, that's the same answer I got there.
Good. Usually, as long as you get the concepts, then the only source of error is if you get the orientation wrong, or if you somehow miscalculate something, or it just could be a careless error, which happens. But hopefully in the test you'll be fresh and you will not make an error. So now in order to make sure that you are getting the concept, let's open up assignment number 3. So for this question number 1, you've got 1, 2, 3, 4 forces. And you're looking for the sum of the moments around A. You've got this angle here, 25 degrees. Right off the bat, 140, it's going to be 0. Why? Because it's passing right through A. You remember that. There's no perpendicular distance, so it's going to be 0. Now, let's take a look at the others. Be careful about this distance because you need to calculate the perpendicular distance. What do I mean by that? So let me show you. This is A. What is this? 200 kilonewtons. This distance is 2 meters. And we have this angle. We have this angle, 25 degrees. What's the distance you need to calculate? So we can use cosine to do that. Cosine 25 degrees is equal to, let's say this is D, equal to D over 2. So D is equal to 2 times cosine 25 degrees. Times 2, 1.81 meters. And that is what you're going to use in your calculation. You don't do that, you will get the wrong answer. Now, let me show you what I mean by that. So you first calculate the correct distances for all of them. So 140 is going to be 0, so don't worry about that. 200, you're going to multiply it by 1.81. 160, you're going to calculate and multiply it by 5.44. 120, you're going to calculate, multiply it by 8.16. And then you're going to get sum of the moment this way. All right. So I'll leave that up for you for a few moments so that you can take a good look and then work on your own. Okay, hopefully we'll be able to get that one correct. So so the answer MA is going to be minus 2211.6 kilonewton meters. And so that's, oops, kilonewton meters, not kilometer newtons. Okay, so that's what we were looking for. Okay. So for the second question, it's pretty straightforward. For MA and MB, I mean, we've done several examples that are similar. This is the solution. So I don't anticipate you having too many problems here. But just keep in mind, this is erroneous. This should be pounds feet. So for 2, you guys catch up. 3 is a bit of a challenge, but I'll clarify how I think you can get it done.
Is number 3 like a tension exercise?
Let me go through it for you. Technically it is. However, it's a lot simpler than what it looks. So in this case, what we're going to do is we're going to use the ratios. So you've got T horizontal, T vertical, and that's what you're going to use to calculate. Now, you're going to replace T using the ratio. So let me go ahead and show that. So because you do have T, but you've noticed that they've given ratio. So this is T horizontal, T vertical, but they've given ratios. What's the ratio? 12 and 5. Now, if you use that ratio, you can then get 13 over here. How? 5 square plus 12 square is equal to, we'll just call this x square. So x squared is equal to 25 plus 1, 44, 169. So x is equal to 13. So what does that do for us? It basically creates a situation where TV over 5 is equal to TH over 12 is equal to T over 13. That's what the ratios are for this angle. So 5 times T, or sorry, what we can do here is, TV therefore is equal to 5T over 13, and TH is equal to 12t over 13. So you're going to use these in your calculations. Because really, now instead of having one force, you have two. And what you're going to remember is that MA is equal to 0. So 0 is then equal to TV times 25. That's counterclockwise, so it'll stay positive. So is TH plus TH times 15. And then you just substitute what we have here. So 0 is then equal to 5t over 13 times 25 plus 12t over 13 times 15. Move this and then calculate t. Oops, I think I made a mistake here. We also have to include 300k, which is clockwise. So you have to add 300k. No, don't get rid of the 13, not yet. Leave it. And you also have to use 300k. And that's multiplied by, it's going to be minus 300 times 34. So this is the equation you've developed. If it looks a little bit confusing here, take a look at the solution. Maybe it'll be a little bit easier there. The answer should be for number 3. Either 434 or 432. And that would be for T. Actually, it's 434. Sorry, not 432. I believe. Okay, for question 2, you keep getting 28,700. Okay, let's take a look. Question 2. What do we have? For MA. Okay, so my question is, so take a look. Did you multiply 500 by 2? And it's a negative. And then 2,000 by 5, it's a negative. And 800 by 9, it's a negative. And then 1,500 by, oh, I see what you did. So this might not be correct. This should actually be 1,500 times 2, 4. No, let's see. Maybe it is correct. 1,500 times 2 plus 4 plus 3. That's 5, and that's 6. Yeah, it is 11. And it's a negative. So this should be 1,000. This should be 10,000. This should be 7,200. This should be 15. Oh, I'm wondering. Okay. Okay. Hopefully that clarifies things. Thank you for letting me know. So now, shall we move on to number 4? Another minute or so. Okay, so number 4. Let's take a look at number 4 to help you guys. So there's a lot of information given. But what the question has already done is they've used this to calculate this density for this plank. It's shown here, 0.72 kilopounds, and it's acting through here. And then for this plank, it's 1 kilo per foot, or 1,000 pounds per foot, and it's 10 feet, so it's already calculated here. So there's only 3 forces that you have to worry about to calculate the moments around A and B. 1, 2, 3. That's all you have to use to calculate the moment around A and B. And I think this might not be 234, it might be 232, but okay. So go ahead and finish that. And then for the last two, I'll give you guys hints, and if you want to stick around, you can finish them or you can head off. Usually you guys leave after 2 hours, so it's up to you if you want to stick around. But once you've finished 4, I will, in this recording, give you guys tips for 5 and 6, and then it's up to you when you want to finish them. You have till the 24th to submit. And I think the link's open. So let me know once you've done 4. I'll give you the tip. Okay, so let's take a look at number 5. So in this case, in number 5's case, did we finish 4? Let me just make sure. I'm assuming you guys have finished 4. And here are the answers. So now take a look at number 5. In the case of number 5, the answer is the same for both, but the way you get to it is a little bit different. So you're looking for MA and MB. Just remember something. You need to simply block out let's see, how am I going to do this? Block this out. Yeah. Don't worry about this. Now that you've got the components, and block that out. What you do want to focus on are these. One, this, this, and of course you've got this one as well. Okay, so that's all you need to focus on. So when you're performing the calculation, just look at the directions and make sure that you understand the distances. Okay, so I'm going to start deleting this so it's not too confusing. Let's go ahead and get that done. And then if you want to verify the answer with me, you're good to go. And for the final question, what you're going to do is just focus on 200 newtons, 500 newtons. That's all you have to focus on. For MA, now don't just ignore the result and just get the moments where we haven't been practicing resultant that much, so I'm not going to ask you to get that. But MA 200 times 2, and it's clockwise, so it's negative. 500 times 1, and it's negative. That's how you get this. MB, this is B. 200 times 2, it's counterclockwise, so it's positive. 500 times 1, it's clockwise, so it's negative. That's how you get that. And same with C. And that will be the end of this assignment. Yes. Uh, Christian Bar. Okay, so if you could pay attention here, let's see what you may have done wrong. So 7.07 times 8, 7.07 times 14, minus 7.07 times 16, minus 7.07 k times 22, minus 4k times 14. If you could take a look. Okay, good. If you guys are done, or if you feel like you've gotten enough, you're free to go, and all the best. But if you want to, I'm going to stop the recording soon. So I'm just going to share what I think are the solutions for the final one, question number 6. Just make sure you are just focused on number 2, on 200 newtons and 500 newtons, and take a look at how it should be done and how it's oriented. So just don't get the resultant. So ignore the resultant, just get the moment around A, B, and C, and I'll consider that correct. Okay, so I'm going to stop the recording now, so that'll be available fairly soon. Once the class is dismissed.